Hello and welcome to Shudeepa tutorial. This is grade 10 CBSE Science, Chemical Reactions and Equations. This is the module 2 video of this topic in which we are going to study balancing chemical equations and conditions required for a chemical reaction. So if you are here to learn how to balance chemical equations or to revise what you have already learned in your previous classes, I urge you to sit with a notebook and a pencil. Chemical equations are balanced based on the trial and error method, so there may be mistakes while you are balancing. You can erase and carry on with the balancing process. Before starting, let's recap module 1. This is an equation in which magnesium plus oxygen forms magnesium oxide, and we had already studied that magnesium and oxygen are called as the reactants while magnesium oxide is called as the product. If you see the number of atoms on the reactants and the product side, you feel there is a mismatch. On the reactant side, there are 2 atoms of oxygen, while in the product there is only 1 atom. Such equations in which the number of atoms are not same on the reactants and the product sides is called as a skeletal equation. That means it is the basic equation just before you have balanced them. Now the question is, why do we need to balance an equation? The answer to this is, balancing of equation is done to prove the law of conservation of mass. You have already studied this in class 9, which states that mass can neither be created nor destroyed in a chemical reaction. This can only be transformed from one form to the other. So let's check the number of atoms in the reactants. The number of atoms for magnesium are 1 in both the cases, therefore they are equal. While in case of oxygen, they are unequal, as I have already stated. So what do we need to do with this unbalanced equation? We need to balance them so that the mass of the atoms on the left and the right side of the equation are equal and it follows the law of conservation of mass. So in this topic, we are going to study in details how to balance a chemical equation. See, in this case, we generally write the number of atoms of the reactants and the number of atoms of the product in 2 boxes. When you will start learning to balance an equation, follow this box method. It will make your work easier. So here in this case, you can compare the number of atoms of magnesium and the number of atoms of oxygen. And you need to convert this one into a 2. And how is that possible? You can do that simply by multiplying 2 on the left to the magnesium. And when you do so, you are actually again making a disbalance in the number of magnesium. There are 2 molecules of magnesium here, and here there is only 1 as of now. So, if you put a 2 over here as well, now see, magnesium has got 2. Here also magnesium has 2 molecules. In the case of oxygen, there are 2 atoms, while in case of oxygen, there are 2 molecules of 1 atom each. Therefore, magnesium oxide, if you see the mass, and in case of magnesium plus oxygen, if you measure the mass, you should find that they are equal. The number of atoms in the reactant now and the product are balanced. Therefore, it is now a balanced chemical equation. You should not get confused here about the 2 which is written on the left of the reactants on the products. These are the molecules, while the 2 that is written as a suffix is actually the number of atoms. Many students get confused on the 2 put on the left and on the right. Now let's see another chemical equation that is given in your textbook. Zinc plus sulfuric acid forms zinc sulfate plus hydrogen. Here the equation is already written. We need to check the number of atoms for the reactants and the products. So let's see the box. The number of atoms for zinc in the reactants is 1. Also in the product it is 1. Here you can see it is 1. In case of hydrogen, there are two atoms here, and in this case, there are two atoms on the right. It is in the products. Therefore, it is balanced. Now let's check sulfur. So here there is one atom of sulfur. Here also there is one atom of sulfur. Hence, sulfur is also balanced. Now let's check the last element, that is oxygen. There are four atoms of oxygen in the reactants and four atoms of oxygen in the product. Right? So this equation seems to be completely balanced. So you don't need to do anything in this. So moving ahead, whenever we are trying to balance equation, we will take one element at a time. I will circle it. You also circle it in your notebook, and gradually we will balance one after the other. Now let's take another equation. Iron plus water forms iron 3 oxide, that is ferric oxide and hydrogen. This is the equation. Fe plus H2O forms Fe3O4, that is ferric oxide and hydrogen. Now let's check the box once again. So iron is one atom, while in the product there are three atoms. In case of hydrogen, there are two atoms in the reactants and two atoms in the product. So it is balanced. In case of oxygen, there is only one atom, while in case of the product, there are four atoms.
So both for iron and oxygen, there are mismatches.
So how will I balance this? So write down this equation in your notebook. Fe plus H2O forms Fe3O4 plus H2. Now let's consider Fe. It's one atom on the left and three atoms on the right. So to make this 1 into 3, I have to multiply it by 3. So now Fe seems balanced. Now let's consider O, that is this oxygen atom on the left, okay, and compare it with the right. It's 4. Therefore, what should I do? I should put a 4 on the left. Now see, even oxygen also got balanced. But in this bargain, what happens is your hydrogen becomes 4 into 2 is 8 atoms total, 4 molecules and 2 atoms each, therefore it becomes 8 atoms. While in this case, hydrogen is just 2 atoms. So it needs to be balanced, right? So what should we do for that? Let's put a 4 here. On the left also, there are 8 atoms of hydrogen. On the right, that is the product, also now there are 8 atoms of hydrogen. So all the elements that were there, iron, hydrogen, oxygen, have been balanced. So this equation is now a balanced chemical equation. Now let's proceed with some more examples. Nitrogen plus hydrogen forms ammonia. NH3 is ammonia. Now let's check the number of atoms. Now I am no longer going to write the box. You can write it in your notebook if you are following this video. Now this nitrogen on the left has 2, while nitrogen on the right has only one atom. In case of hydrogen, there are 2, which is unequal with the 3 over here. So what should I do? Let's try putting a 2 on the right. What happens now is n gets multiplied twice, which gets balanced here. But if you do so, you have to remember that hydrogen becomes 3 multiplied by 2, that is 6. And how much is this? This is only 2. So what should you do for that? Should I multiply here a 3 on the left? Therefore, hydrogen on the left, that is the reactants, also becomes 6. Now it seems balanced. There is 2 for nitrogen and even 2 for nitrogen on the right, that is the product. Here there are 6 for hydrogen. Here also there are 3 into 2 is 6 for hydrogen. Therefore, this equation is balanced. Till now, we have been considering the equations just in the form of elements. But to make the chemical equations even more informative, the physical states of the reactants and the products must be mentioned along with the elements. whenever you are trying to express a chemical equation. So what should I write for that? I can write the notifications like G, which stands for gas, L, which stands for liquid, AQ, which stands for aqueous, and S, which stands for solid. Do not get confused seeing L and AQ. L is written when the element is in liquid form in the normal condition. AQ is written when the element is dissolved with the liquid for a reaction to take place. So these are two different things. So henceforth, I'll try to write the physical states of the reactants and the products. So let's see the first example. Sodium chloride. You know sodium chloride is a solid, that is common salt or the table salt that you see. I have made a solution. So I have written here aqueous plus F2, that is fluorine, which is a gas, forms sodium fluoride, which is a solid, and chlorine, which is again a gas. So I have mentioned the physical states of the reactants and the products. Now let us start balancing one by one. So let me consider sodium on the left and sodium on the right. In both the cases, it is 1. Seems balanced, right? Now let us see chlorine. Chlorine on the left and chlorine on the right, they are not balanced. Chlorine on the left is 1, while chlorine on the right is 2. So to make this chlorine on the left to a 2, should I multiply it by a 2 on the left? And if I do so, what am I also changing? I am also changing sodium now. So I have put a 2 in front of sodium on the product. Now let's consider fluorine. Fluorine on the right becomes 2, while fluorine on the left was already a 2. Now if you consider sodium, chlorine and fluoride on the left and the right, they have the same number of atoms. Therefore, the above equation is now balanced. So this is how you have to proceed. Take one element at a time and then balance it on the left and the right. But again, I am saying on doing so, you may need to revisit one element repeatedly. Therefore, you should always balance an equation with a pencil, erase it in case you have to revisit. Now let us look at the conditions that are required for a chemical equation. To make a chemical equation more informative, like we write the physical states, we also write certain other important information. You can see here a chemical equation. This equation depicts the process by which green plants produce their own food. What is that? That is photosynthesis. In photosynthesis, carbon dioxide and water in presence of sunlight and chlorophyll produce simple sugar and oxygen. C6H12O6 is simple sugar. Here, in this case, for the first time, I have mentioned certain things above and below the arrow that we always write for expressing chemical equations. These are actually the conditions that are necessary for chemical reactions. Here in this case, the reaction happens in presence of sunlight and chlorophyll is a must because the magnesium ion of chlorophyll actually absorbs the sunlight and allows this photochemical reaction to take place. So you can say these catalyze the process of photosynthesis. Other than that, for a chemical equation to take place, the reactants may be very close or in close contact to each other. They may be in the solution form, like just now I have mentioned AQ, aqueous. So maybe in some cases the solid reactants do not react. You may need to form an aqueous solution by adding water or maybe by adding any kind of acid. So a solution form may speed up the reaction or may allow the reaction to happen. Heat, light and catalyst. What is a catalyst? A catalyst in chemistry is any substance that increases the rate of a reaction without itself being consumed. That means, in this case, sunlight and chlorophyll actually allow the process. They do not form any product in the reaction. Therefore, if you notice this chemical equation, you can see the products of carbon, oxygen, and hydrogen only has formed simple sugar and oxygen. Nothing from sunlight or chlorophyll has become a part of the product of the reaction. This was all for today's video. Like, share, and subscribe to Shudipa tutorial. Do solve the questions that are present in the box on the left. In the next topic, we are going to study about the different types of chemical reactions. Till then, take care. Bye.